and taught you how to solve a system using matrices. Now, I don't know if y'all remember, but you learned how to solve systems in ninth grade. Does anybody, you don't have to write this down, I'm just going to quickly review how you would have learned to solve this in ninth grade. It was something called elimination. Does that ring a bell? Your goal was to eliminate one of the two variables. Obviously, we have x's and we have y's. The x's are kind of hard to eliminate because they're two different numbers and they're both positive. The y's are going to be a little bit easier because one's negative, one's positive. If that were a 2, isn't negative 2 plus 2 0? So it kind of cancels itself out. Well, remember you just multiplied that whole equation by 2, which made it a 4x minus 2y equals 32. So now that's gone because we multiplied everything in it by 2. And now look, all you did was add them. That becomes 10x. That cancels out because 2 minus 2 is 0. And then 78 plus 32 becomes 110. Then you just divided by 10 and got x equals 11. And then does anybody remember what you would then do to find y? Right, you could plug 11 in for this x or this x and then solve for y, and you would know your y. Do y'all kind of remember that from ninth grade? There were two other methods you learned in ninth grade. The other one was called substitution. I'm not gonna do it completely because it'll take time. But substitution is when you took one of the variables and isolated it. So like, we could add this 2x to the other side, but then since the y is negative, you would divide by it, and it would make that negative and that negative. And now that y equals negative 16 minus 2x, you would have substituted all that for y. And now see how this problem has nothing but x's in it? And you would just distribute and solve for x. Do y'all kind of remember substitution? And then the third way that we learned, which we're definitely not going to do, is graph it. Couldn't you take each of those equations and solve, put them both in y equals mx plus b form and graph them? And where they cross each other would be the solution. So no matter which way I do it, you get the same answer. Shh, guys, please be quiet. Alright, so the first thing that you would do is you would set up a matrix equation. Now, to be able to do that, they have to be lined up. See how the x's are lined up, the y's are lined up, and the constants are lined up? So in the first equation, the elements would be 2, negative 1, 6, and 2. The second matrix would be the constant values, 16 and 78. And then to actually solve this and figure out what the x and y are, all you have to do on the calculator is take the inverse of the coefficient matrix and multiply it by the constant matrix. Okay, and I'm sure you did that yesterday. What did you get? 11 and 6. Okay, that's your x value, that's your y value. So like if we had taken the time to graph these two lines, they would have crossed at over 11 up 6 is where their intersection would have been. Okay? Alright, now flip to the next page. Okay. Today we're basically doing the same thing, except for they didn't give us the two equations, they gave us sentences. And you're going to have to take it from sentence form and make it an equation. Some of these are easier than others. Find the value of two numbers if their sum is 13 and their difference is 3. Do we know what these two numbers are? Well, I mean, before we start the problem, do we have any idea what these two numbers are? Not yet. Not until we've actually done some math or thought about it. So, the two numbers are what we call unknowns. And don't we use variables for unknowns? Now, is there any guarantee that these two numbers are the exact same number? No. So we need to definitely use two different variables because there's a good chance that it's going to be two different numbers. Now, one thing they tell us about these two numbers is what? Okay, but before that, what did they tell us?
The sum is 13.
Right, the sum is 13. What does sum mean? Right, when you add these two numbers, you get 13. And then they also told us another statement about these two numbers. When you do the difference of them, you get 3. Now don't we just have a system of two equations that we can put in a matrix equation? So what will my elements be in this first matrix. Isn't that a 1, 1, 1, negative 1? Okay, and for my constant matrix, the values that are not beside a variable, 13 and 3, and to actually solve this and figure out what x and y are, you take the inverse of this matrix and multiply it by that one, just like yesterday. So go ahead and type that in and see what you get. Okay, once you typed it in, what'd you get? 8 and 5. So what that means is your x value, since it's first in each of the equations, it's 8, and your y value is 5. Now, once you get your answer, you're going to want to make sure they actually make sense. Is the sum of those two numbers 13? Is the difference 3? Yes, so it works. All right, example 2. The sum of two numbers is 21. So how do I write that as an equation? X plus y equals 21. Okay, so those kind of statements are very easy to write as an equation. Now let's look at this next one. One number is 3 less than the other. Okay, x minus 3 equals y. Or you could have chosen y minus 3 equals x. It doesn't matter because they don't specify which number is 3 less. They just tell you one of them, so you get to choose which one it is. Now, I'm ready to put this in a matrix, but what's the problem? Why can't I go right ahead to the matrix? They're not lined up. Your x's are lined up, so like we know that's a 1 and a 1 for each of those, and this y is in the correct place, but these are in the wrong place. So how do I get this y over here? Right, I add it over there. So now on this side I'm going to have a plus 1y. And then this 3, it doesn't need, oh no, I don't add it. I should have subtracted it, right? Yeah. Sorry, I just listened and didn't pay attention. Okay, it was already positive, so it should have been subtracted over, making it a negative 1y, making this a negative 1. The 3 was negative, so it has to be added over. And so now in this matrix, the two elements are what and what? 21 and 3. Because since it was minus 3, to move it across the equal sign, you change its sign. You're basically just picking up the y and the 3 and exchanging them, but they cross equal signs, so their sign changes. Okay, so now to find the answer, you just take the inverse of this one, multiply it by this one, and the matrix that pops up is your x and your y. So go and do that. 12 and 9 is correct. Those two numbers really add up to 21, and one of them is definitely 3 less than the other, so they make sense. Okay, example 3. A collection of quarters and nickels is worth $1.25. There are 13 coins in all. How many of each are there? Okay, we have some unknowns here, because obviously we're trying to figure out how many quarters there are, how many nickels there are. Now, normally for unknowns, we just go with something like x and y, but when you have something so specific here, I like to go for variables like q and n. That way I know this is quarters, I know that's nickels. Now, obviously, we have two equations. Otherwise, you wouldn't be able to solve it using a matrix. You have to have at least two equations. Tomorrow, we're going to move into having 3. Okay? Now, what are our two totals here? Right. And it doesn't matter which order you do them in right now, because right now everything over here stays is the same. Okay, now here's where you want to pay attention. This statement is all about the total number of coins, right? We're saying we have quarters, but we don't know how many, and we have nickels, but we don't know how many, but we know they total up to 13 total coins. So we're going to add the quarters and nickels, and we know they make 13 coins. This statement is all about the value of the coins. Well, don't we know the value of a quarter? So we can put 0.25. Okay, so let me go back to what I was saying. This equation is all about the value of the money here, right? So we know the value of a quarter. We know the value of a nickel. What's the value of a nickel? 0.5. Right. And the reason that you have to write those is because we need to know of the $1.25, you know, that a quarter is worth that much of it, and then a nickel's worth that much. Now that you have those two equations, you're ready to set them up. So go ahead matrix and then multiply it by the constant matrix, which is your totals. And then type it in. And then always check your answer. Make sure it works. Okay, what'd y'all get? Okay, so that would be 3/4 and 10 nickels. Okay, well obviously that works for this statement. It makes 13 coins. How much money is 3/4? 75 cents. How much money is 10 nickels? Does that really make $1.25? So it works. Okay, next page. I'm doing 2 more with y'all before you start trying them on your own. Alright, example 4. Suppose you bought 8 oranges and 1 grapefruit for a total of $4.60. Later that day, you bought 6 oranges and 3 grapefruits for a total of $4.80. Now you want to find out the price of each orange and each grapefruit. Okay, so obviously you can use X and Y if you want, but I'm going to choose to use O and G. And the reason I'm making it like a fancy O is so I don't mistake it for a 0. Now, what are my totals for the equations? 460 and 480. Now, when it comes to the 460, what all was involved in that total? Right, 8 oranges plus 1 grapefruit totaled up to 460. What? That's oranges. Okay, so when the total was 480, how many oranges were bought? And how many grapefruits? 3. Now you have your 2 equations. You're ready to make it a matrix and solve it. Okay, so hey, what did you get? Turn around, please. 0.5 and 0.6. What is that 0.5? 50 cents. So if it helps you, you can put just a 0 after it, and then that's 60 cents. So let's make sure this makes sense mathematically. If you buy 8 oranges, and oranges cost 50 cents a piece, how much money would that be? $4. If you buy 1 grapefruit, and they're 60 cents a piece, that would be 60 cents, which makes sense that your total came to 460. If you buy 6 oranges at 50 cents a piece, how much money have you spent? And then 3 grapefruits at 60 cents each is, which does total up to 480, so that makes sense. Okay, you should always check them to make sure they work. You decide to invest a total of $1,000 in 2 interest-earning bank accounts. The checking account pays 4% annual interest. The saving account pays 6% annual interest. Guys, people will try to watch these videos to relearn this, and they might not be able to hear. At the end of the year, the total amount of interest earned was $58. How much money did you invest in each account? Okay, what variables would you like to use? Okay, I did C&S for checking and savings, but you don't have to. What are our totals here? 1,000 is one of the totals, and 58 is the other total. Now, we know that, like, you have 2 bank accounts. One's checking, one's savings, and we know that together they total 1,000, but do we know right now how much is in each one? No. Okay, so for this one, remember, we have no idea how much money is sitting in that checking or how much money is in that savings. We just know together there's $1,000. Now, this total is all about interest. Well, don't we know how much interest is on the checking account? 4%. And then 6% on the savings, and then you just put them in your matrix. And then I'm assuming, well, I don't know if you finished that one because I don't know if you knew how to do that. But go ahead and type it in and see what you get, and then make sure it works mathematically. Okay, Kiara, right? What'd you get? I gotta move on. You should have got, no, 100 and 900. Which makes sense. They do total to 1,000. And then if you do the math, what's 0.04 times 100? Do the math. 0.04 times 100. 4. And what's 0.06 times 900? 54. And doesn't that add up to 58? So it works. Okay, I'm going to go over number 2, and then you're going to try the rest of this page and the next for homework, and tomorrow I'll go over them. I'll try. Number 2, pay attention. This one gets a little more difficult. The sum of two numbers is 8. So how do I write that as an equation? Okay, the first number, which it doesn't really matter, but we wrote x is the first number for this one, so we'll just put x as the first number of this one, is, what does is mean in math? Equals. 2 more. How do you write 2 more? Plus 2. 2 times the second number. How do you write 2 times the second number? 2y, because y is the second number. Now all you got to do is rearrange it so that you can put it in a matrix. So what has to happen before you can put it in a matrix?
You have to
Right, the 2y belongs over here beside the x, correct? So we need to subtract it over there. So now that equation becomes x minus 2y equals 2. So you can basically ignore that, and here's your two equations, which is 1, 1, 1, negative 2, and then 8, 2. Take the inverse of the first one, multiply it by the second one, and then make sure your answer makes sense. Okay, what'd y'all get? What? 6 and 2. Do those sum up to 8? Isn't 6 2 more than 2 times that? Like if you take that and double it, you get 4, and then 2 more is 6. Okay, so you need to finish this page and the next page, and tomorrow we'll go over questions from those.